All right, welcome to Chapter 10, Section 1, called Geometric Mean. This is for Integrated Math 2, or IM2. The first couple of things that you'll see on your screen here is a due date. I don't see a due date on my teacher's screen, but you will see it on your student side. The second thing is the number of attempts. Remember, you always have unlimited attempts on homework, tests, and quizzes. Number of questions just tells you how many are in the particular assignment. Grading policy is best score, so whichever attempt is the best one is one you get to keep. Partial credit is enabled, so if you answer 1 of 3 questions correctly, you get credit for the one question or however many you answer correctly. Down here it says, please remember once you start your homework, you must finish it before you can work on anything else. And what that means is once I click start in the bottom right corner, I will see the submit assignment button. I need to make sure that I click that submit assignment button to finish my assignment. And by not being able to work on anything else, what it means is it's going to lock out your account. So it's going to lock out your assignments, it's going to lock out your resources, it's going to lock out your grade book. So really your account just kind of gets locked until you click submit assignment. And what Alex is doing is trying to leave this attempt open for you instead of closing it for you if you just close the tab or you close your computer, so that you can come back and continue to work on it. Remember, you have unlimited attempts. You do not need to leave the attempt open. And it's also going to save your progress. So whatever you've worked on already, it's going to save that for you. So just very good habit. Always click submit assignment when you're ready to leave, even if you haven't quite finished yet, because it saves your progress there. On the side here we have explanation, example, and message center. Explanation tells you you're going to lose your question attempt because it's going to give you the answer to this question. So it's not going to give you the answer unless you come type it in. Example shows you exactly what it is we're kind of going to be doing here. So we're going to be looking at these, and I'm going to have, I did this in class too. We draw the 3 triangles, kind of separating them out so we can actually see them, because if we have this situation where we have this perpendicular, it's not really a bisector, it doesn't bisect the angle, doesn't bisect the bottom line, but we have a perpendicular line going through the vertice, then it's going to create 3 similar right triangles. And it has to be going through a right triangle as well, the larger one here. So we're going to go through and we're going to redraw these and kind of look at that relationship, and then solve for the last few pieces here. It wants us to write a similarity statement for the 3 triangles, which drawing them makes that very easy, and then we can also take a look at the proportions for filling them in. You can look at another example if you like. You can also message your teacher directly from the screen so we know where to come help you. All right, so first step is I like to take this and draw the 3 triangles. So I have the first triangle, which is the very large triangle here, and I know it's not going to be perfect. You know what? I'm going to use my lines here just to make that a little bit nicer. Try to make that very perpendicular there. Something like that, and like that. And I'm going to lasso this guy, copy and paste, and then I'm just going to dial it down a little bit. So this would be the medium triangle. Let's go a little bit bigger for our medium triangle. And then we also have a small triangle, which we want to dial it down even smaller for our smaller triangle. Now I'm going to add some labels in here. So the larger triangle was J, L, K. So we have our right triangle there. The medium triangle was actually this guy, but I flipped it around so that I can see it in the same way. So the right angle is here, which is M. And then going across the bottom, that would be L also. So the L's still match up here. They're not the same angle, but they're both labeled L. And then the bottom would be, or the top would be J. Those are the same angle. They're overlapping. So this whole triangle is included. So these 2 are the same angle here. All right. And then we have the last one. So the right angle is right here, which is still on M. They're not necessarily referring to the same angle. One of the M's is on top and one of the M's is on the bottom. They're both 90s, so they're very similar there, but they're not referring to the same angle. So then going across the bottom leg would actually be going K, and then going to the top would be L, like that. So the ones that match in this case would be K, and J, and J, like that. So those angles match. And then we can see all the 90-degree angles that also are congruent to each other. So now that I have them written out in this way, I can go through and I can start to say J, K, L. So I went in this direction. I went down to the K and over to the 90, which is L. So I'm going to go J, L, M for the next one. J, L, M, because I'm going to go down and over. And then I'm going to do the same thing for this one. L, K, M. L, K, M. So it takes a second to draw these, but definitely going to help put them in the right order. And if you put these letters out of order, it will mark you wrong. The corresponding order matters. J goes with J, goes with L. J, J, L. The middle ones is K, L, K. K, L, K. And then the last one is L, M, M. L, M, M. So it's the corresponding order matters in the placement when you put the letters together. All right, so now we're going to write the proportion. So LK, so we have LK and JK. So that's going to be this one here. I'll use a different color. So we have LK and JK. So these two are going to be proportional to, and then we have KL. And the only other one we have KL in is this one. So JK and KL are corresponding to each other. We can see that, JK and KL. So now I have LK, that corresponds with MK. Because they're similar triangles. The side lengths have to be similar. So again, separating them out makes that a little bit easier to visualize. All right, the next proportion we have is JL and MJ. So it's not this JL, it's this one. Because I have LM as well. Oh, it's JM. Oops, this side. Ha ha ha. Still right triangle. I was just drawing on the wrong side. So we have JL and JM. So I know JL is here, and LM. I don't think there's any other JM actually. This is the only one with JM. So we just need to make sure we're choosing the right triangle when we're looking at the proportions. So that way we can compare it to the next one. So then we have JK. This is the only JK that we have. None of the other ones have JK on it. So this corresponds to JL, and I want this other length here. So since it was JM, I want JL. So this is just another way to write the proportions when I have a perpendicular line drawn in a right triangle. It creates these proportions because it creates three similar right triangles that I can separate out. So it's a little bit different. We have to see that visually. I think the visual of it definitely helps me. So I hope that helped you a little bit there. All right. The next piece is we have a geometric mean. So this is actually still part of this same triangle because we have a right triangle here. The whole big thing is right triangle. And then we have this perpendicular line drawn through, which is going to create two more smaller right triangles. So we still have this same situation here. We don't have all the same labels. Is it gonna let me get rid of the arrows? Yeah. But we still have the same triangles. So if I'm looking at this one, this is the large one, and I have the bottom leg is 3. They have this angle labeled as 1, which would also be this angle here. And then this whole length is Z, which would be this guy here, Z. And they want us to find Z. So let's see. Oh, you know what? I think this is actually a length. I always look at that as an angle. So this is 3, and then I think what they meant was that this piece here is 1, not the angle. That was silly when I was looking at that. So on the smaller triangle, this length is 1, and then Z would be this whole piece here. So if I'm just going to focus on the large triangle and the small triangle, remember they're similar, so I can have bottom to bottom, so KL to KM, which would be 3 to 1, and that's going to equal these pieces here. So, and with this piece here, I have to make sure I'm kind of thinking of it, let's see, because we have Oh, this is also 3. I forgot to fill that in because this would be the length of the smaller one. So I'll have z to 3. Like that. So, sorry, forgot to fill that in. So this is actually where the geometric mean comes in. So the length here, the 3, is the geometric mean between the whole side and the first piece. So I can do the same thing if I were to, draw this guy, and I know I'm not drawing it perfect here, but I can say that this length is the geometric mean between the whole side and the short side here. Or I could go from this length, and this is going to be the geometric mean between the whole side and the first piece here. So I can actually write these two proportions. These will work. So we kind of arrived at this just by looking at the similar triangles, but this works without having to really separate them out. I can just use this geometric mean idea of, okay, well, I'm looking at this side here, and I'll go back to blue so that that's not confusing. So I'm looking at this side here. I know this is z, or this is 3. So this is my geometric mean between the entire side, which is z, and this smaller piece, which is 1. And I can write this piece here. So what the geometric mean is that it's going to be 1 is on top and 1 is on the bottom, and then I'm going to have the small piece over the whole thing, like this. So small piece, the whole thing. Really doesn't matter which one you wrote, which direction, because we're going to do cross multiplication here. So it's going to be z equals 9. So it's just a different way of looking at that, but we arrived at it the same way we did, where we separated 3 triangles out and we look at the proportionality of the sides, but you can also use this geometric mean that just kind of helps you arrive at it a little bit faster. All right. The last one here, we have proving the Pythagorean theorem using similar triangles. So let's see, can I get rid of all this stuff, or is it not going to let me do it? Oh, I don't have to redraw all my triangles. All right. So the main thing. Oh man, it's not gonna let me change the size of the eraser. All right. Well, we'll just figure it out here. Okay. So the large triangle, instead of J, it's A, and then C and B, like that. So I have A, C, B, A, C, B. I just flipped it around so it matched my little diagram. The medium triangle, I have A, D, C. So A, D, and then C. I'm just going to leave that one C there. The small triangle, I have C, D, B. So C, D, and then B there. I guess I can write C there just so you know that they're both C. So we can see those. And then let's see, for the small triangle we have, this is called A and N. Those are lengths. And then for the medium triangle, I have B and M. And then for the larger triangle, I have, so AB, this would be M plus N if they're going to ask us to add them together. I'm not sure if they're going to ask us to add them together yet, but it would be this whole length here. And then I would have AC is B and CB is A, like that. Okay, so a little bit sloppy just because I have some of these other labels in here, and for some reason it won't let me open my eraser sizing, so I can't change the size of it. All right. So if we're looking at this for completing the proportions, we have B over something equals C over B. So if I'm looking at C over B, where's the length C? Oh, length C, right there. C, and it should be M, it should be C. So C over B, these are the only two as far as the pieces here, but they also want us to look at the proportionality. So I'm gonna do it both ways here, just so that we can kind of see what's going on with the geometric mean, because that definitely matters as far as this goes. Because we have a right angle, we have a right angle. So if we're looking at B and B, that's my geometric mean here. So I'm actually looking at this length on this side. This is B. So this is going to be the geometric mean between the whole thing and the first piece. So if I have the whole thing here, which is C, the first piece is going to be M. Like that. Oop, not capital M, lowercase m. All right, and then I have A and A, so that's my geometric mean. So let's change this guy up to yellow, why not? A is on the other side here, so now I'm looking at this side. Doesn't write as nice, the chisel marker doesn't write as nice on going that direction for some reason. So it's very thin. So I have A, remember that's going to be the whole side again, but now it's going to be to the smaller piece that starts on that side. So I have the whole piece already, C, and the smaller side is going to be N. So we're using the geometric mean. I think that actually is a little easier to look at than the 3 different triangles. Just looking at the geometric mean in that way. So use the method of cross product to rewrite the equation. So cross product literally means they want us to cross multiply. So B times B is B squared. And then C times what? Well, we filled it in with M, so it's going to be C times M. A times A is A squared. C times N. So they're just not giving us that fill in the blank because then they would know, what we filled it in with. And now use part 2 to fill in the blanks. So they're saying A squared plus B squared. Well, they're just adding A squared and B squared. Well, A squared is C times N. So I'd have C times N on this side, and B squared is C times M. So we're just literally, we kind of added everything together. So I added the squares on the left, and I added the products on the right. So now we're using the distribution property, and we're undistributing the C because they're both being multiplied by C. So we can see that that's outside of here. So I have N and M like that. And then use segment addition property. And I kind of already alluded to this one, that it would, forgot to turn off my line tool. M plus N is this length here, which is C. So this is equal to C. M plus N is the segment addition that would be equal to the entire length of C. So then now we're going to use substitution again to rewrite, instead of N plus M inside of the parentheses, well, I'm just going to replace it with C. And then C times C is C squared. So this kind of gave us some steps. We stepped through finding the Pythagorean theorem, which is A squared plus B squared equals C squared. So this is how we can find a missing side length of a right triangle. So it's just kind of a way to go through and prove it. This is how you prove it, is using this geometric mean idea. All right, let's go ahead and check this guy, make sure we're good to go there. Yay! All right, so that was section 1, and I will see you in section 2.